Hey everyone, it's Mr. Ference. We are going to continue our look at two-dimensional kinematics and look at projectile motion today. So you should already have watched the video on vectors. What we're going to do now is take that math stuff that we've been talking about and apply it to projectile motion, to kinematics and studying how things move. Very quickly, I'm going to define this word projectile. What this is an object that's moving in two dimensions. So it's moving in the x direction and the y direction at the same time, under the influence of gravity. So gravity is acting on it and pulling it down towards the center of the Earth. Its path is going to be a parabola. So we're going to see this characteristic mathematical shape. In order to understand it, we have to look at the x motion and the y motion separately, just like we were talking about with vectors. The reason we're doing that is because gravity only is acting in the vertical direction. Gravity is only going to affect its motion in the y direction. It is not going to affect its x direction, its x motion at all. What that means is that, first of all, our x velocity is constant. So the speed or the velocity that it's traveling in the x direction, that's going to be the same for the entire time that it's in the air. In the y direction, this object is going to move with constant acceleration. That's 9.8 meters per second, straight down towards the center of the Earth. And that is going to be true for all objects, regardless of mass. So check out this picture for a second. These two balls were dropped. They were released at the same instant. The yellow ball was projected forward, so we see that parabolic shape. The red ball was just dropped. It's free fall, right? Just straight down. Because gravity is acting on these both at the same rate, what you can see is if you compare the vertical, the y coordinate of each of these, they're about the same at every single instant where this camera was taking photographs. That means they're getting pulled down at the same rate. They're moving vertically at the same rate, even though the yellow ball's moving forward. They're falling the same distance at the same time. So they're actually going to hit the ground at the same time. That seems weird and counterintuitive, but it's true. Don't write these down yet. What I want to do is take those things that we were talking about the x velocity and gravity and stuff, and I want to sort of change and simplify our kinematics equations. So right what we have here are three of our four kinematics equations. The fourth one isn't going to be as useful in this unit. It's really just going to be these three. I've written them both down. The only difference between the ones on the left and the ones on the right is the subscript. Okay, so these are all happening in the x direction. So I'm saying x equals and vxi. These are all happening in the y direction. So this is y and vyi and vyf. But other than that, they are exactly the same equations. They're exactly the same as the ones we've been using already. Now, like I said, in the x direction, there is no acceleration. It's going to be traveling at a constant velocity. And in the y direction, it is going to be traveling with that constant acceleration, g, 9.8. And so what I can do is I can sort of rewrite these equations and simplify them a little bit. So I can wherever we see A, I'm going to plug in G to show that it's gravity. And here, everywhere we see this A term, if we put in 0, that's just going to disappear. So all of these A terms will just vanish because A is 0. What that's going to do for these x equations is it's going to mean that this first equation is sort of useless. It's obvious. It's telling us is that our final x velocity is equal to our initial x velocity. We already know that. Same thing with this third one. So a lot of this is going to vanish except for this middle equation. So check this out. Okay, don't write these down yet. But now we've just sort of changed them a little bit. We've adapted them. We've gotten rid of some of the useless stuff in our x equations. And what I'm doing now is I changed all the A's to G's just to show that this is being accelerated by gravity. There's one more thing that we can do to simplify this. In this unit, everything that all the projectiles we're going to look at are going to be launched horizontally. meaning at an angle of 0 degrees. The reason we're doing that is because if you fire this up at an angle, we have to use trig, we have to use like sine and cosine and stuff to figure it out. That can get a little messy. So we're not going to do that. We're going to keep it simple. What that means is right here as it's being fired is that its initial y velocity is 0. This is acting in the y direction sort of like it's been dropped, right? Just like the problems we've been doing. So what that means in those y equations is all of those vyi terms are just going to disappear. And so our equations are actually going to simplify a little more. So here's the final form of our equations. You can go ahead and write these down. These equations are the kinematic equations that we've been using. They're the same thing. It's just that since these ones are only for the situation of projectile motion, they've been sort of simplified and changed around a little bit. But they're still the same kinematic equations. We still use them the same way. So write these down. Make sure you have them in your notes. If you're like keeping up index cards, add these to the index cards or make another index card. These are our main equations for this unit that will help us navigate these problems. As we're solving these projectile motion problems, here's our process. It's pretty much the same process that we've been doing so far. So step 1, don't panic, take a deep breath. You got this. Drawing a diagram, even if it's just like some stick figures and some stuff, that can be helpful to visualize stuff and just help you organize your information. Make a list of what you know and what we don't know. Write down those variables, just like you've been doing. Keep in mind that the X motion and the Y motion are not the same thing. We cannot use them interchangeably. We have to look at them one at a time. And then you're just like we've been doing, we're going to pick an equation, we're going to proceed. You will almost always have to use more than one equation. Like we'll find one thing using an equation, and then we'll plug that into a second equation. So we're now going to see 2-step problems, 2 or 3-step problems. The most important thing for you to find here is time, because if you look at these equations, the only variable that shows up on the X side and the Y side of things is this time, because obviously the time that the projectile is in the air is the same regardless of which direction you're looking at. So that's what we need to do. Make sure you have these equations. In class, we will look at solving some example problems, and then we'll go for that. So good luck. I will see you soon. Take care.